Hello everyone. In this short demo, I'm going to show you how to deploy vllm-Omni on Kubernetes, or in this case, OpenShift. vllm-Omni is a framework that extends vllm, the inference server, to support omnimodality model inference and serving, understanding omnimodality as text, image, video, and audio data processing. It also supports non-autoregressive architectures like diffusion models, for example, or diffusion transformers. And it also supports heterogeneous outputs. So you can generate beyond traditional text outputs. So as you can see in the screen, we are in the New England Research Center OpenShift cluster. And I'm going to show you a little bit the structure of the Kubernetes manifest that we have created. We are using Customize in order to organize all the manifest. And there is a base layer where we define the namespace for isolation, a deployment, a config map in order to configure which model we are going to use, a service, and of course a secret in case you want to use a gated model in Hugging Face. You can include the Hugging Face token here. And then in the overlays directory, we have two variants, Kubernetes one, where we are using an ingress, and the OpenShift one, where we will be creating a route. In this case, for deployment, it's just as easy as applying the overlay that you need. In this case, it's the OpenShift overlay, and all the resources will get created. So as you can see, namespace, config map, service, the deployment, and finally the route. Let's check how the route looks like. We check the route in the vllm-Omni namespace, and there you go. This is the endpoint that we have to call in order to generate images. So now we go to the OpenShift dashboard. We enter in the vllm-Omni namespace, and we check a little bit the deployment topology. So we have a pod, a service, and a route. And let's check a little bit the pod logs of the vllm-Omni server. In the events, you can see the pod has been scheduled, the image is being pulled, and there you can check the logs. vllm is starting, and we are using the Z image turbo model. I'm going to fast forward a little bit the logs because it takes a little bit for the first to start. We see that the server is loading the model. And now the server has started, all the endpoints are ready, and we can start sending queries. So what we are going to do now is basically send a simple prompt, a llama eating GPUs, to the vllm-Omni endpoint or route, as you can see in the top of the command. It's basically a curl command where we send the message and some extra parameters like the height and width of the image we want to generate, a set of inference steps, a number of inference steps, a seed in order to kind of randomize the output. And as you can see as well, the output of the server is an encoded image in base 64. So we are going to decode that output and store it in a file called llama.png. So we send the command, and we are going to check a little bit the logs in the server. We get the prompt, a llama eating GPUs. The prompt has been properly received in the server, and we will be waiting for the output generation. And we got the response completed. And now we are going to see the generated image. So this is a llama eating a kind of a GPU, right? And what we are going to do now is basically send the same command, but we are going to change some of the parameters. For example, the seed, so we get a different kind of output, and the number of inference steps. In case, we can experiment to see what is the result by changing these parameters. We are storing the response in a different file. And again, we will wait for the outcome and see how the logs in the server are going. So finally, the image has been generated, and we can compare the llama2.png with llama1.png and see how the image is different. It is still a llama eating some kind of GPU. And that's all for today. We have vllm-Omni on Kubernetes. Thank you very much.